Problem number 31 says that two forces act upon an object. And so we have this one force, and let's see, it says 25 and 40 pounds act on an object. The force of 40 pounds acts along the positive x-axis, and so we're going to take this 40, and that's going to go along the positive x-axis. The force of 25 acts at an angle of 80 degrees. And so let's do this in green. So 80 degrees is something like that, and that's a 25 pound force. So find the magnitude and direction of the resultant force. So we're going to take the blue vector and we're going to move it up. So we have tail to tip, there's a 40, and since this guy right here, that's 80 degrees, right? That's 80, okay, and if that's 80, then that means that this right here is also 80 from there to there, because this guy is also 80. As that's corresponding angles to the two blue vectors represent parallel lines, the green vector represents your transversal, and if that's 80 right there, then this angle right here is 100 degrees. And so our resultant vector would be this vector right here, the red one. And sorry for that. Let's see. Let's put an arrow there. And we're just going to call that the length of the vector, x. And then we're also going to be finding a theta right here that represents the angle that this resultant vector makes with the horizontal. And so we use the Pythagorean, no, not the Pythagorean theorem, we use the law of cosines to find x. So we get that x is equal to the square root of 25 squared plus 40 squared. And then we have minus 2 times 25 times the cosine of that 100 degree angle. Okay, make sure you're in degree mode. And the number you should have gotten, I think it's 51. I'm just looking at the answers. I'm assuming you can plug that into your calculator. You should get magnitude of 51 pounds. Okay, it said to round to the nearest whole number, so all I have is an answer key here. And so normally, as I have said a million times, you need to round to the nearest 3 digits after the decimal. But nevertheless, 51 pounds is the magnitude of the vector, and we're going to store that. So it's 51 point something, but we're going to store that value in A, and then we're going to use, oh, here's what I want to do. We have this triangle here that we're going to make sure that we put an angle, let's call it alpha, and we would use the law of sines to find the measure of alpha. So we would say the sine of alpha divided by the side opposite is equal to the sine of 100 degrees divided by that value that you just plugged in for A. Okay, and then you get that alpha equals the inverse sine of, and you've got a bunch of stuff over here, so that's 40 times the sine of 100, and we're going to divide that by that x. Okay, and so we get alpha, and alpha is approximately, let's see here, thank you for waiting, 29 degrees. Okay. Oh, no. Oh, shoot. It's not going to be 29. It's going to be that 80 minus 29, which is 51. So the alpha is 51 degrees. Okay. We don't want alpha. That's not our end result here. We want theta. And remember, theta, then, it would be theta plus alpha is going to equal that 80 degrees. And if we take the alpha and subtract it from 80, we would get that theta is approximately equal to 29 degrees. And so that's it. That's the answer. We have our magnitude 51, and we have our theta, the direction, would be 29 degrees as we labeled in the diagram. Okay, that's our theta. Okay, so I hope you're having a good night. If there's anything else, let me know.